Okay, so our next important topic is parallel plate capacitor. But now we will be inserting a conducting plate in between the plates. So how it will change the capacitance, how the charge will fluctuate, how the charge density will change. So all this we will discuss in the next few slides. Okay, okay. So suppose we have a parallel plate capacitor of plate area A and distance D connected to a battery, positive and negative terminal. So this plate will be positively charged and this plate will be negatively charged. So right now we have negative charge on this plate and positive charge on this plate. Now suppose we insert a conducting plate between these two plates. So this is a conducting plate. Suppose the thickness of this plate is T. Now this is a conducting plate. It means it will have free moving electrons and the electrons will come out from an atom, so that atom will be positively charged. So there will be positively charged atom in this plate and negatively charged electrons also. So what will happen that this negative will attract positive on this side and this positive will attract negative on this side. Now in a conductor, in electrostatics, value of electric field is zero. So basically in this region, in this thickness T, there will be no electric field. There will be electric field in this region and this region, but in this thickness there will be no electric field. So now we have to derive capacitance of this parallel plate capacitor. So in this conductor, in this conducting plate, the value of electric field is zero. We have already derived that the value of electric field between the capacitor plate is sigma by epsilon. So in this region, in the conducting plate is zero, but in the region except this, the electric field will be sigma by epsilon in this region and sigma by epsilon in this region, where sigma is surface charge density, that is charge divided by area. Now coming back to the formula that we have already derived, that V is equal to E into D, that potential difference is equal to electric field into distance. Now between these two plates we have to calculate potential difference. So V is basically equal to electric field into distance. Now sigma by epsilon is in the region between these plates but not in the conducting plate. So thickness of conducting plate is T. So except this conducting plate, the thickness will be D minus T. So sigma by epsilon is present in D minus T, and in the remaining, that in thickness T, the electric field is 0. So 0 into T will come out to be 0. So potential difference is Q by A epsilon D minus T, since sigma is surface charge density. So if you don't know, then sigma is basically equal to sigma is surface charge density, that is charge divided by area. So putting the value of sigma here, that is Q by A. Now if you will put Q equal to CV, that we have already derived, that Q is equal to C into V. V and V will cancel out. So capacitance will be given by epsilon naught A divided by D minus T. If you will see that the denominator has now decreased, so capacitance will increase. So inserting a conducting plate between two parallel plates of a capacitor will increase the capacitance of that capacitor. Okay, now this is how we calculate capacitance when there is a conducting plate inserted between the two parallel plates of a capacitor. Okay, moving forward, suppose there's a question that a capacitor of plate area A and distance between plate is D is connected to a battery and charged. So now we have a capacitor of capacitance epsilon naught A by D. It is connected to a battery of potential V and charged. So charge on capacitor will be equal to Q equal to CV. C is epsilon naught A by D and potential difference is V. The battery is disconnected and a conducting plate of thickness D by 2 is inserted between plates. So now the battery is disconnected, there is no battery now, and a conducting plate of thickness D by 2 is inserted between plates. Find final charge, final potential difference if initial charge is Q and potential difference is V. Now remember this thing, that capacitor is charged by a battery. So if there is no battery, then the capacitor will not get charged. And in this question, we have charged the capacitor from the battery. Now we have disconnected the battery. So now neither the charge can increase nor it can decrease because there is no battery. So the charge on the capacitor will be Q and minus Q. The charge will not change, but capacitance will change because now we have inserted a conducting plate between the capacitor plates. So C will be equal to epsilon naught A divided by D minus T. Here T is D by 2. So putting value of T equal to D by 2, the capacitance now is 2 epsilon naught A by D. Again putting the formula Q dash equal to C dash V dash. So the charge remains the same. So Q dash will be equal to Q. So on the place of Q dash, I have put epsilon naught A by D into V equal to. The new capacitance is 2 epsilon naught A by D into V dash, the new potential difference. So the new potential difference is what epsilon naught A by D will cancel out with epsilon naught A by D and V dash will be equal to V by 2. So the final charge will be equal to initial charge, but the final potential difference will be half of the initial potential difference. Always remember, if you disconnect the battery, the charge on the capacitor plates can neither increase nor decrease. It will remain the same because the battery is charging the capacitor. So if you remove the battery, then if capacitor is already charged, it will remain charged. Okay, you can't increase or decrease the charge without the help of battery, but you can change potential difference and electric field. Now coming to the next question. The same question, but with a little difference that a capacitor plate is connected to a battery in charge. So there is a capacitor of capacitance C, epsilon naught A by D. It is charged with a battery of potential difference V, so Q will be equal to CV. Now a conducting plate of thickness D by 2 is inserted between plates, but remember, the battery is not disconnected. Find final charge, final potential difference. Initial charge is Q and potential difference is V. Now there is battery. So if now the capacitance will increase, so what is capacitance? Capacitance is charge storing capacity. Now if potential difference is increased, the capacitor will store more charge because battery is there, battery can give more charge, it can supply more charge. So new capacitance is epsilon naught A divided by D minus D by 2. So it will come out to be 2 epsilon naught A by D, and Q dash will be equal to C dash V dash. So putting the value of C dash, putting the value of V dash. Now potential difference is V only because now we have a battery of potential V. So potential difference will not change because previously also the potential difference is V. Now also the potential difference is V. But charge will change. So Q dash will be equal to C dash into V dash. So what is the value of new capacitance? 2 epsilon naught A by D into V. And what is epsilon naught A V by D? It's Q. So putting the value of Q here. So the new charge will be twice of the previous charge, but the potential difference is same. So if the battery remains connected, charge can increase or decrease, but potential will remain same. But if battery gets disconnected, then charge can neither increase nor decrease, but potential can change. So based on this video, now you have to submit an online quiz. So there are many tricky questions in the quiz. You have to solve them, and if you have any doubt, you can contact me. Okay.